Hello friends, welcome to a lecture series on essential mathematics for machine learning. Now in machine learning, to develop various algorithms, we should know fundamental knowledge of mathematics. Now calculus is an important part of in machine learning. So in this topic, in this today's lecture, we will deal with basic concepts of calculus. So we will start with functions. So what functions are? So this lecture is a very basic lecture and it is meant only for those who have either forget about the functions and their properties, or might be they have not studied this topic earlier. Okay. So what do you mean by function? So let A and B be two non-empty sets. Okay. Then a function from the set A to set B is a rule or correspondence which associates elements of set A to the elements of set B, such that to each element of A there exists one and only one element of B. If f is a function from A to B, then we denote f from A to B. So what do you mean by this? So let us see what I try to say, that you have set A and here you have set B. So function f is a correspondence between these two sets from A to set B, such that if you have any element here in A, okay, you have a one image in B, in the set B. Okay. That means that each element of set A has an image in B and that image must be unique. So if a mapping or a rule satisfy these two properties, what are those two properties? The first property is that every element of the set A must have correspondence in set B, and the second one is that correspondence, that image, that link, that correspondence from set A to set B must be unique. So if you have these two properties from set A to set B, or you have a map f from set A to set B such that these two properties are satisfied, then we say that it is a function. Okay. So suppose I am taking here 5 elements in the set A, suppose you are having some elements here also in set B. So we have a correspondence here, say this element maps here, this element maps here, this element maps here. So it is a function. Okay. So if you have a linkage like this, say one element is giving two images here in B, so it is not a function. Say it is set A, it is set B, and we have a some map f from A to B such that one element of set A has two images in B, so it is not a function. So it is a function. Here whatever we have defined is a function. Okay. So this set A is called domain of the function. So basically domain of the function is basically all those elements in this set A. Okay. We can say that domain of the function are all those elements where function is defined. Okay. And the image of this A in B, see here in this example you have one element whose do not have pre-image in A. Okay. So this image, basically this set is called range of the function f. Okay. And this entire B is called codomain. So this A set is called domain of the function, domain of f, and this B is called codomain of f, codomain of f, and this and range of f are basically all those y in B such that y equal to f x and x belongs to A. Okay. So this is how we can define function. So let us take few examples to determine domain and range of a function. Okay. Because if you want to learn basic concepts of calculus like differentiation, like partial derivatives, continuity and all those things for which various algorithm is based, we must have first of all knowledge of functions, what functions basically are. Okay. So, let us discuss few example based on this. Suppose you have a function f(x) equal to, okay, we will take a next slide. Suppose f(x) is equal to x square, okay, and you want to find out the range and domain of this function. So, how you will find out range and domain of this function? See, first of all, is it a function? So, if a graph of a map is given to you, how will you determine that the given map is a function or not? So, see, first of all, before discussing this example, we will discuss that how by simply the picture of a graph, how can we say that whether it is a function or not. Say you have this type of function, say like this type of graph you are having, sorry, okay. If you draw a line parallel to y axis here, so say for one x, here it is x axis, it is y axis, okay. So, for one x you are having two different y. So, that means you are having this type of point, that for one x you have two y. So, it is not a function. So, similarly here for one x you are having two y. So, we will say that it is not a function. Okay. Now, say you have this type of figure, you have this type of graph, this is a straight line. Now, if you draw line over here parallel to y axis, for one x you are having only one y. You draw line here parallel to y axis or anywhere, if you draw a line parallel to y axis, for one x you are having only one y, that means this is a function. Now, say you draw another graph, say you take this graph. Now, if you draw a line parallel to y axis over here, for one x you are having two y, again it is not a function, because for one x the image should be unique as per the definition of a function. So, it is not a function. Suppose you are having this type of figure, okay, we can draw plenty of figure like this type of figure. So, if you draw a line parallel to y axis anywhere, either here or here, you draw line parallel to y axis over for any x, then you will observe that for one x you will be having only one y, here also anywhere in the graph. So, that means it is a function. So, that means if a picture of a graph, if a graph is given to you and you want to predict whether this is a function or not, you simply draw a line parallel to y axis, vary that line over the entire graph, and if for every x you will be having only single y or unique y, then you can say that it is a function. Otherwise, if there exists a point on the graph where for a single x you will be having two different y, that means it is not a function. So, this is the first thing. Now, next let us talk about that example again, f(x) equal to x square. So, what is the graph of this function? The graph of this function is like this. So, is it a function? So, answer is yes, because if you draw a line parallel to y axis anywhere, so you will get only one y. So, that means it is a function. Now, if it is a function, so what is the domain or range of this function? We are taking as a real valued function. Okay. So, what is the domain of this function? So, domain of f will be, you can clearly observe that you take any real x, there will be f, value of f, fine. So, this means this is defined for every x, for every real x. So, that means domain of the function is whole real line. Whole real line means from minus infinity to plus infinity, anything. Now, if you talk about range of this f, so you can observe that only the positive y axis is covered. We are not, you put any x, say you put minus 1, then minus 1 whole square is plus 1, you put 4, it will be 16. You will never get a point in y, I mean in this real line where in this y axis where y is negative. So, that means the range of the function is only from 0 to infinity. So, 0 is included because when x is 0, f is 0. So, this is how we can talk about domain and range of the function. Okay. So, we say this function is from R to R. So, domain will be the whole real line, however, the range is only a subset of this. Okay. Now, let us talk about another example, say f is f x equal to sin x. Okay. What is the range and domain of this function? So, we know that sin is defined for every x, for every real x. You put x equal to -1, -2 or any other real x, it is always defined, domain of the function will be whole real line. Now, what is the range of this function? Now, range of this function will be simply equal to -1 to +1, because sin is always lying between plus and -1, it can never exceed 1 or it can never be less than -1. We already know this, as if you draw the graph of the sin x, the sin x will be something like this. Similarly, here. So, this value is 1 and this value is -1. So, sin x always lying between -1 to +1. Now, take another example, say f x equal to say under root 1 minus x square. Now, let us try to figure out that what is the domain and range of this function. Now, this function is defined, it is a real valued function, and this function is defined when this under root, the expression inside the under root is greater than or equal to 0. So, when you put 1 minus x square greater than or equal to 0, I am doing it here, 1 minus x square greater than or equal to 0. So, this implies x square minus 1 is less than or equal to 0, and this further implies x minus 1 into x plus 1 is less than or equal to 0. When you plot the number line, it is 0, it is -1, it is somewhere +1, and you put x equal to 0, then x equal to 0 will make it -1, which is satisfied. That means from -1 to +1, this inequality is satisfied. So, this implies that x belongs to -1 to +1. So, when x belongs to -1 to +1, this under root is defined. So, we say that the domain of this function is -1 to +1. Okay. And what about range of this function? Now, again when you talk about the range of this function, now this is an under root, and the expression inside under root is always positive. We may have 0 also when x is +1 or -1, this value is 0, but whatever is obtained from inside solving this expression, after solving this expression will be non-negative. So, we say that the range of the function will be 0 to infinity. So, these are few examples of defining range and domain of the function. Now, let us take one more example based on the fraction. Suppose f x equal to say x upon x plus 1, and you are interested to find out domain and range of this function. First of all, domain. Now, domain of f will be all those real x where f is defined. Okay. Now, this f is defined everywhere except x equal to -1, because at x equal to -1 it tends to infinity. Okay. So, we will say that the domain of this function will be what? All real number except -1. And what is the range of this f? Range of this f will be, now to determine the range of this f, we can put it like this, say this is y, okay, y equal to x upon x plus 1. So, this implies y x plus y is equal to x, and this further implies x into y minus 1 equal to minus y, and which further implies, this finally implies x equal to minus y upon y minus 1. So, you can see that y can never be 1, or you can simply take x tending to infinity. When x is tending to infinity, this expression will tends to 1. So, that means f will never tends to, I mean it is tending to 1 when x is tending to infinity. So, that means y can never be 1. So, the range of this function will be whole real line except 1. So, this is how we can define a domain and range of a function. So, next let us see what are the other properties of function. So, this I have already discussed. Now, there are different type of functions. What are different type of functions? Now, the first function is constant function. What is a constant function? So, let f from a to b is a function where a and b are two non-empty sets. Okay. If f x equal to alpha for every x belongs to a, where alpha belongs to b is a fixed real number, then f is called a constant function. That means, for every x f is giving a constant value. So, that is a constant function. Suppose f x equal to 2 for all x belongs to R. Oh, so we are defining f from R to R. Okay. Okay. So, what is the graph of this function? So, say this is x axis and this is y axis, and for every x in R f x is 2. So, this is the graph of this function, a constant function, which is here it is parallel to x axis. This is f x equal to 2. So, what is the domain and range of this function? So, domain is the entire real line. So, domain is R, of course, because everywhere it is defined. And what is the range of this function? Range of this function is singleton set 2. Domain of this f will be what? Whole real line, and range of this f is what? Only singleton set 2. Okay. Now, next is identity function. Now, function that associates each real number to itself is called identity function. So, identity function is basically f x equal to x. Okay. This type of function is identity function. For every x, f maps to itself. Okay. Clearly, it is a straight line which passes through the origin, and the domain and range of this function is R. Okay. Next are odd functions. So, what are odd functions? A function from a to b is said to be an odd function if f of minus x equal to minus f x for all x belongs to a. So, we have various examples of odd functions. Let us see odd functions. Odd function means f of minus x equal to minus of f x for all x belongs to R, or for all x belongs to A, we can say, because we suppose it is defined from A to B. We are saying that f is defined from A to B. Okay. So, let us see few examples of this. Suppose f x equal to say x cube, function is from R to R, suppose f is from R to R, and it is function is x cube. So, if you take f of minus x, it is what? It is equal to minus x whole cube, which is minus x cube, which is equal to minus of f x. So, that means this definition of odd function is satisfied over here. So, this function x cube is an odd function. So, what is the property of an odd function? The property graphically, how can we visualize whether the given function is an odd function or not? So, to visualize this, simply if you draw the graph of the function of an odd function, the graph of x cube is what? Graph of x cube is something like this. So, it is symmetrical about origin. If you take the graph of the two nodes, I mean 2 points from origin, and if you interchange, so it will give symmetrical about origin, okay, like this. Say you can take another function, say f from R to R, and it is defined as say sin x. Sin x also f of minus x comes out to be minus sin x, which is equal to minus f x. That means it is an odd function. Now, if you draw the graph of this function again, here also it will come out to be symmetrical about origin. Okay. So, similarly, we have so many examples of a function which are odd functions. Now, next are even functions. So, what are even functions? Even function are those functions where f of minus x equal to f x for every x in A, and even functions are always symmetrical about y axis. So, say you have this example, say take another example, say f x equal to x square. If you take f x equal to x square, f is from R to R, then f of minus x will be what? Minus x whole square, which is equal to x square and which is equal to f x. So, this function is an even function, and if you draw the graph of this function, then the graph of this function is something like this. So, this function is symmetrical about y axis, So, odd functions are those functions where f of minus x equal to minus of f x for every x, and even functions are those functions where f of minus x is f x for every x. Okay. And graphically we can also visualize that odd functions are symmetrical about origin and even functions are symmetrical about y axis. Now, comes to other functions, modulus functions, a very important function, modulus function. So, modulus function is denoted by mod of x, and it is defined as it is x when x is greater than or equal to 0 and it is minus x when x is less than 0. That means, this function is always positive, is always non-negative in fact. Okay. You take mod of minus 2. What is mod of minus 2? Mod of minus 2 is 2 itself by this, because minus of minus 2 is 2. So, this function is a modulus function. So, is modulus function an even function or an odd function? So, it is an even function. You can simply see that if you replace x by minus x here in this definition, then mod of minus x will be x, I mean mod of x. So, this is an even function, and what is the graph of this function? See, if you take the modulus function f from R to R, which is f x equal to mod x, that means it is x when x is greater than or equal to 0 and it is minus x when x is less than 0. If you take this function and you draw the graph of this function, so when x is positive it is this line, this portion of the line, and when x is minus x it is this line. Okay. So, it is basically symmetrical about y axis. You can clearly observe that it is symmetrical about y axis. So, it is an even function. Okay. And of course, what is the domain of this function? Domain is the entire real line, that is R, and what is the range of this function? Range of this function is 0 to infinity, close interval 0 to infinity, because 0 is included, because when x is 0 it is 0. Now, next is greatest integer function. Now, what is greatest integer function? So, say you take f from R to R and it is defined as f x equal to box x, is sometimes called as box x. So, what is box x? Box x is basically the greatest integer less than or equal to x. Suppose you want to find out box of 2.7. Okay. So, box of 2.7 is 2, because see, there are so many integers which are less than or equal to 2.7, like 2, 1, 0, minus 1, minus 2 and so on, which is the greatest one is 2. So, it is the greatest integer less than or equal to 2.7. Suppose you want to find out greatest integer of 3 is 3 itself, okay. Less than or equal to is there na. So, suppose you want to find greatest integer 1.6, it is what? Minus 2, greatest integer less than or equal to minus 1.6. So, if you draw the graph of this, what is the graph of this? Now, from 0 to 1, at 0 it is 0, at 1 it is 1, not 0. So, we are open from here, and from 1 it is 1, and when you have a value between 0 to 1 it is 0 only. From 1 to 2 it is 1, and at 2 it is 2 here, okay. At 3 again it is 3, at 4 it is 4, like this. Now, at 0 it is open here, and at minus 1 it is minus 1. Similarly, here it is open and here it is minus 2, and similarly this. So, this is a step type function. So, this step type function is basically greatest integer function. And what is the domain and range of this function? The domain and range of this function is entire real line. Okay. Next is exponential function. We are already familiar with exponential function, that is a raised to power x type of function is basically exponential function. So, if a is e also, then it is exponential function of base e, fine. Here we are defined a greater than 0 and a should not equal to 1. Okay. Logarithmic function is a function where f x is log to the base a x, where x is greater than 0, log x to the base a, we read it like this, is a logarithmic function. So, these are important functions which we use. So, how we can draw exponential function or logarithmic function? So, if you take exponential function say a raised to power x, where a is not equal to 1 and a is greater than 0. So, there are two cases which may arise. If a is greater than 1, if a is greater than 1, then the graph of this function will be something like, because when x a is greater than 1, as x tends to minus infinity it will tends to 0, and when x tends to infinity it will tends to infinity, then the graph of the function will be something like this. At x equal to 0 it is 1. Okay. This is y equals to a raised to power x for a between a greater than 1. Now, if a is between 0 and 1, suppose half, if it is half, then half raised to power x is what? I mean half, if it is half, then if x tends to minus infinity, it will tends to infinity, and if x tends to infinity it will tends to 0. So, in this case the graph of the function will be something like this. So, it is y equal to a raised to power x when when a is between 0 and 1. So, this is how we can draw, I mean you must have an idea of these basic functions. These are very simple and basic functions which you use frequently. So, we must have a graph, we must know that how we can plot this graph, or what are domain and range of these functions, whether these functions are even or odd functions or not, or they are neither even nor odd, like this function is neither even nor odd. Okay. So, we must have an idea of this. If you say that what is the domain and range of this function, then domain is clearly the entire real line and the range is only positive y. You see that you will be having range only positive y, you are not giving any x, for any x where y is negative. So, the range of this function is 0 to infinity. Okay. So, what is the domain of this function? Domain of f will be what here? Domain of f is entire real line and range is what? 0 to infinity. Okay. So, likewise we can also think for exponential function. Now, there are some other properties of function. The function may be 1 1 or onto or many to 1 or into. So, let us discuss these concepts also, that how when we can say the function is 1 1 function or many to 1 function. So, a function f from a to b is said to be 1 1 if different elements of a have different images in b. Hence, if x y belongs to a such that x not equal to y implies f x not equal to f y, then f is called 1 1 function. So, what do you mean by 1 1 function? So, if you are having, say you are having a function from a to b, suppose if you are having different x in a and those x have different image in b, and it is true for every different x y in a, then we say the function is a 1 1 function. That means, for all x y belongs to a where x not equal to y, it should imply that f x should not equal to f y. So, this is called 1 1 function. Okay. Or we can say that, or we can define this as, if f x equal to f y implies x equal to y and it is true for all x y in a, then we say that, because if two images are same implies the pre image is also same, that also means the function is the 1 1 function. Now, let us take one example. Suppose f from R to R is defined like this, f x equal to say x cube minus 1 or anything. Okay. Now, if you take f x equal to f y, where x and y belongs to R, it implies x cube minus 1 equal to y cube minus 1, it implies x cube minus y cube equal to 0, it implies x minus y into x square plus x y plus y square equal to 0, and since this is never 0 for any real x and y, then this implies x equal to y. So, this f x equal to f y implies x equal to y. So, this implies f is 1 1 function. Okay. Next is many to one function. So, for many to one function you have, if there exists x and y in A for a function f such that two different points in A or elements in A have same image in B, then it is called many to one function, 2 or more than 2 in A. Okay. Here we are taking 2 points, it may be 3 points also. That means there exist, if there exist x and y belongs to A such that x not equal to y implies f x equal to f y, then we say that the function is many to one function. Like you take f x equal to x square and function is from R to R. It is also important that from where to where you are taking the function. Okay. This will decide the points x and y in A. So, if you take f of minus 1 which is equal to f of 1 equal to 1. So, these are two distinct points in x or A and having the same image 1 in B. So, that means this function is many to one function. Okay. So, now what is an onto function? So, I told you that onto function is basically what? When range of f is equal to codomain. So, let us try to understand this concept also. Say you have a function from A to B. Okay. So, if you take any point here in B and that point, that element has a pre-image in A, then we say that the function is an onto function. Okay. So, that means for every y in B, there exists x in A such that y equal to f x. So, then we say that the function is an onto function. Okay. If it is not happening, if there exists some element y in B whose pre-image does not exist in A, then we say that the function is an into function. In that case, range of f is simply a proper subset of codomain. Okay. So, let us take now this example x cube plus 1. Okay. So, a function which is 1 and onto both is called bijection map, bijective map or bijection. Okay. So, let us take this example x cube plus 1 and we have to show that this example is an bijective map or bijective function. So, how we will show this? So, here function is from R to R and f x equal to what? X cube plus 1. Now, we have already shown here like x cube minus 1 or same way we can show for x cube plus 1 also that this function is an 1 1 function. Okay. So, similarly we can show for x cube plus 1 also that it is an 1 1 function. So, f is an 1 1 function. I am directly writing here. You can follow the same lines as we did earlier to show that x cube plus 1 is a 1 1 function. Now, how can we show that it is an onto function? Onto means for every y in this R, there will always exist a pre-image in x, I mean in the domain set. Okay. So, say it is y equal to, we are writing x cube plus 1. So, it implies y minus 1 equal to x cube and it further implies x equal to y minus 1 raised to power 1 by 3. So, you take any real number, you can simply see here, if you take any real number y, so there will always exist a cube root of that number and that will be x. So, that means for every element in real in B here is, in this example B is R. So, for every real y in R, there will exist a pre-image in A. So, that means this map is an onto map. You can see graphically also that if you draw the graph of this function, see it is when x is 0 it is 1, okay, here somewhat here. So, it is going from here and then here, it is something like this function. Okay. Now, you can see that when you draw a line parallel to x axis anywhere, you will be having only one point for every x, there will be only one y for this function. You take a line parallel to y axis, for every x there will be only one y. So, that means it is a 1 function, and for onto you see that the entire y axis is covered. This is a real y axis, real line, and the entire real line is covered. So, that means it is an onto map. So, graphically also you can visualize whether a given function is 1 onto, many to 1 or what. Okay. Now, if a map is an bijective map, then its inverse exists. So, how we define an inverse of a function then? Inverse in that case, suppose f from a to b is a bijective map or a bijective function, then a function from g from b to a which associates each element y in b to a unique element x in a such that f x equal to y is called the inverse of the function f and denoted by f inverse. Like take this example. Okay. Let us try to find out the inverse of this function. So, what is f here? So, f is defined from r minus 1 to r minus 1. Okay. And how it is defined? F x equal to x upon x plus 1. So, now if you want to show this function is, first of all we have to show that it is 1 and onto, then only we can talk about its inverse. So, for 1 how we define 1 you take f x equal to f y, which implies x upon x plus 1 is equal to y upon y plus 1. This further implies x y plus x is equal to y x plus y and implies x equal to y. So, this means f is 1. Okay. Now, for onto, how we can discuss for onto? Either graphically you draw the graph and try to show that there will always it will cover the entire real line except 1 for onto, or you can interchange x and y as, see, y equal to x upon x plus 1. This implies y x plus y is equal to x. Okay, then this is x into y minus 1 equal to minus y, which is x equal to y upon 1 minus y. So, see, except 1 which is not here in codomain also, except 1, this is for any y in R there will exist x in R. That means, for every y in here, for every y here in this set, you will always have a pre-image here. So, this means this function is an onto function. Now, what is the inverse image of this? Inverse image is given by this expression itself. Inverse image, inverse of f y, inverse of this is simply y upon 1 minus y. This is the inverse of this function. So, that is how these are some basic concepts of functions, where we have seen that what functions basically are, how can we define domain and range of the function, what are the very basic functions like identity function, constant function, modulus, greatest integer function or exponential functions. Then we have also seen that what are other properties of function like 1 functions, onto, bijective map, etc., and based on that how can we define f inverse. So, these are the fundamental things of functions. In the next class we will see that how can we discuss about a limit, continuity or differentiability of these functions. Thank you.